Hello everyone, this is Doug Young. Today I wanted to kind of talk to you about the periodic table of elements, say a couple words about its origin, and then talk about the groups and periods, metals and nonmetals, halogens, alkali metals, those types of things. Just give you a basic introduction of the periodic table of elements. A word about just a little history here. Back when physicists and chemists were discovering the elements, this is when, first there were like 4, then there were 12, then there were 40. They were discovering these elements at a pretty rapid pace back in the 1800s. And so there's a debate on how to organize these, right? Scientists love to organize things, categorize things. And so there's one camp that wanted to organize, the elements based on their masses. So by their atomic mass. How much do they weigh? So start with the lightest ones first. You just list them in order, smallest to largest. But there's another camp that really wanted to list them, that wanted to group them by their properties. So they really wanted to group the elements by their properties, by their chemical properties. How did they react? What did they do? What did they look like? And there's kind of a debate, which one would make more sense, which one would be better, which one would be useful. And there ended up being a compromise. So if you take a look at these elements, right, you have something like helium, which is an inert gas. Inert just means it doesn't really react with things very quickly. It's pretty stable, doesn't do much. And following helium is an element called lithium. And if you take a look at lithium, lithium is a shiny metal. It's a shiny metal and it reacts with water. If you put a hunk of lithium in water, it'll kind of sputter around, create hydrogen gas and lithium hydroxide. If you continue down, and we're going to skip beryllium, boron, etc. for now. If you continue down the list of elements, you get to neon. Neon is also a gas and it is also inert, doesn't seem to really react with too much. And immediately following neon in terms of atomic mass is sodium, which is also a shiny metal and also reacts with water. If you keep on going down the periodic table, we get to argon. Argon is also an inert gas. And if you know nothing about potassium, you probably can get the point by now, right? Just looking at the pattern. Potassium, also a shiny metal. Also a shiny metal, also reacts with water. And so what they noticed, right, the argument was, as far as this grouping goes, is that these properties show up periodically. These properties are repeated periodically. And so people wanted to organize them in that way, which is what gave us the periodic table of elements, right? So properties were repeated periodically. Were repeated periodically. And so if you organize them together, both by mass and by their properties, you get what we now refer to as the periodic table of elements. Now the periodic table of elements, the discovery of which, of the first periodic table that's sort of put together, was usually given to Dmitry Mendeleev, a Russian chemist physicist, who decided to list them in order of mass, which on this, if you look closely, he did, right? First hydrogen, which weighs very little, and then lithium at 7, beryllium at 9, boron at 11, 12, 14, 16, 19, 22, 24, 27, on and on and on. So they're in order from top to bottom, left to right. But he also grouped them together, right? He also grouped them together. So if you take a look at this, right, this group 1, so group 1, group 2, group 3. Group 1 is what we would now call the alkali metals, lithium, sodium, potassium, rubidium, cesium. So we also grouped them by their properties. What were some of the properties that these elements exhibited? What's really cool about his periodic table of elements, Mendeleev's periodic table of elements, is that he was confident enough that this was the way things should be organized, that he left gaps in it. So he didn't feel compelled like, oh yeah, we already know all the elements, so I need to kind of make that all fit. He knew that there were things that we were missing, that there were elements that we had not discovered yet because there were holes, there were gaps in his table. And so he predicted, with really no evidence other than his organizational skills, that something should exist that weighed around 72 and something should exist that weighed around 68, which is amazing. We now know later, after this periodic table was published, that these ended up being elements gallium and germanium. So gallium and germanium on the periodic table, just for example. There were others that he predicted, but he was able to predict like the properties, the mass, like I was saying earlier. And he pointed out how the periodic table they developed could be a really good predictive tool and how important it was to organize these elements by their properties. Nowadays, our periodic table looks a little bigger, right? Instead of just having 60-something elements like on that previous table, we now have 118, so we're much larger than we were before. If you take a look at the periodic table elements, there's so much information on here. It's not just a list of their atomic symbols and the names and their masses. There's a ton of information. I just want to show you a couple of features in this video, and I'll show you more of the periodic trends later. But what you may notice on your periodic table, it's not on this one, but you might see, for example, a red line on here going zigzagging across the periodic table like this. What that red line signifies is the difference between the metals and the nonmetals. So over here to the right of this line, so to the right, these would be all of your nonmetals. To the left of this line, these would be all of your metals. Now when we hear metals and nonmetals, we think of metal as like a gray thing that's probably hard, right? But by metals, really we're talking about some pretty complicated orbital stuff having to do with conductive bands and things like that. But really for us, metals are things that are conductive, right? So it's a metal if it's considered conductive, and that means conducts either heat or electricity. Oops. Electricity. So heat and electricity. Nonmetals are just the opposite, right? If they're not conductive, they're insulators. So nonmetals are insulators. Which is probably a good thing for living creatures, right? We're made out of mostly carbon and hydrogen and oxygen and stuff, all these nonmetals. Nice that they insulate us from like a winter's cold day or something like that, right? If you put on a jacket made out of copper, you would get really cold really fast because it would just transfer all your heat away from you. We put on a coat now, it's not made out of metal, we make it out of insulators like cotton, which again is made out of carbon and hydrogen and oxygen, just totally different properties of these elements. I do need to say though, however, that hydrogen is in an awkward spot. Hydrogen over here in group 1, the first element, is put over here in group 1 for a lot of different reasons that we'll talk about later. Tends to give a +1 ion, has 1 valence electron, but really it is not a metal, right? It's over here on the left-hand side of that red zigzag. It's not a metal. It's really a non-metal. It belongs over here on the other side. So that's the only oddball with that trend. You will notice also, you may have heard about semiconductors, right? So not metals, not non-metals, but semi-metals or metalloids are semiconductors. And those would be elements that sort of touch these this red line. So elements like boron, silicon, germanium, arsenic, antimony, tellurium, things like that, polonium. If it's these shaded ones, these would be the metalloids or semi-metals. And like I said earlier, they're called metalloids or semimetals, and they're neither insulators nor conductors. They're semiconductors. And you may have heard that term, right, when you think like a semiconductor is like a computer chip or what's in your phone or whatever, right? Semiconductors are nice because you can make them conductive and not. They can be switches. You can turn them on and off. And you may have heard of, for example, Silicon Valley, where a lot of this technology is popped up, right? So silicon being the most common element that you make semiconductors out of. So the periodic table can be divided into metals and nonmetals, with a few of them being considered metalloids or semimetals. But they also have more specific groups, more specific names. So let's talk a little bit about the groups and the periods. If I take a look at some of the groups, right, so we have groups, quote-unquote groups. Groups are the columns. And for us, this is our introductory level type of class. For us, we're going to use what's called the the A method for naming the groups. So we have 1A, 2A, 3A, 4, 5, 6, 7, and 8A. I'm not going to put the A because we're not comparing it, the A system versus the B system. The big difference with the A versus the B system is that we skip this middle chunk here. So for the one that we want to do in class, just because this could be more useful when we figure out things like valence electrons, is go 1, 2, skip the whole middle thing, 3, 4, 5, 6, 7, 8. The other method, the B method, includes those. So 3 would be at the scandium, 4 would be at titanium, 5 would be at vanadium, 6, 7, 8, 9, all the way up to 18. So there's two different ways you can number these groups. We're going to go with the A method, 1, 2, 3, 4, 5, 6, 7, 8. So you've got the groups that are the columns, and then you have the periods, which are the rows. So periods are the rows. Oops, not the rounds, the rows are the rows. So by rows, I'm talking about here, like here's the first row, the second row, third, fourth, fifth, sixth, seventh. So I have 7 rows on the current periodic table. Maybe there'll be 8 if we discover a new element. Sometimes you'll see in books or online or practice stuff like that questions like, what is the third row period, or sorry, the third row group 4 element. And when they're asking that, right, so they're asking the group 4. So I know group 4 is this group apparently, so here's my group 4. And they're asking about what period? The third row, the third period. So here's the third row, the third period. And if they're asking what that element is, then apparently they're talking about silicon. So your answer would be, oh, they're talking about silicon. That's the group 4 element that is in the third period, that's in the third row. Now these groups have more specific names. I've already said before, a lot of things like noble gases, for example. So we do have more specific names for these groups. We'll put some on this periodic table. So group names. The first group, group 1 here, these are what's called the alkali metals. These are the alkali metals, so this group 1 stuff. But we're not talking about hydrogen, because remember, hydrogen's not a metal at all. It belongs over on the right-hand side. We're talking about everything but hydrogen. So all of the rest of this group, lithium, sodium, potassium, rubidium, cesium, francium, all the rest of those. The second one are the alkaline metals, or alkali earth metals, alkaline earth metals. Alkaline earth metals. And like I said, that's all of these. So beryllium, magnesium, all the way down to radium. This next chunk are the transition metals. All of these metals that are down here in that big dip between, for us, what's group 2 and group 3. So all of those from scandium down to zinc. We're not going to get too hardcore into the definition, whether or not zinc is considered a transition metal. For us right now, everything in that block right there, transition metals. If we keep on going, there are more names for some of these other elements like pnictogens and stuff like that, but what's important for us are the halogens. Those are really common. Halogens are your group 7 elements, so fluorine through iodine. These down here. And then we have on the far right-hand side the noble gases. So the noble gases, helium, neon, argon, etc., all of those. There is a group down here that we're not going to really talk about too much in an introductory level class, but these are the rare earth metals. Rare earth metals. Like I said, we won't really see them in my introductory level classes, but these are the lanthanides and actinides. They actually have the names over here. And those are really big elements that we're not really going to talk too much about. But I do want you to know these group names. Alkali metals, alkaline earth metals. By the way, those names are Arabic, from meaning like from the ash. The alkali is from the ash. They're discovered and sort of how to make really basic solutions using ash. Then we have the transition metals. Halogens are group 7 stuff. Noble gases are group 8 things. Those are really the big key ones that I want you to know. So there's a brief introduction to the periodic table of elements, some of the groups, the difference between a group and a period. What I will talk about next time is how to look at the periodic table of element. What do all these numbers mean in terms of protons, neutrons, electrons? Some about the Bohr model, the periodic trends. All of those will be very important things to be discussed in other videos. So I hope that you've learned a little bit more about the periodic table, and I will talk to you soon. Take care.